know, um, today uh, experiment. There's in my previous video there is a description I made that I will do. There's the experiments I want to conduct. Okay, if you check here, this is a generator pass, electrical pass. So the engine part have already been removed. Okay, so this is a modified coil statue. This is the lotto. This is the two battery 12 volts. So I will use it to run the motor because the motor is can operate on 12 volts, 24 volts, and 36 volts. So it can operate on 12 volts, 24 volts, and 36 volts. So this is the frame I make for it. So okay, so here is a factory wind starter generator. You can see. So here is the factory wind generator. So if you check it. So it only has the capacitor wire and the mains. So the output. So here is the the lotto, the armature. So that is it. I will experiment with this. So here is my modified statue. So you can see it has a lot of output. It has a lot of output. Here is the capacitor. Then this is for battery charger, direct battery charger. Then here is a series parallel. Yeah, the output, the main output. So just the yellow wire is for, and the white wire it is for output. So it's a modified uh, stator I make. So I just designed it so that I will. This is a solar charge controller. So you can see rated voltage is 1224 volts. The maximum current is 50 amp. The max PV voltage, yeah, the input voltage this solar controller can handle is 50 volts. So in 12 volts, 650 watts, 24 volt, 1300 watts. So this is the solar controller. So what I want to do is I will use a diode, then convert this direct DC to AC to DC, then feed it here. Then let me know if it will be charged the battery instead of making use of this type of charger by plugging it uh, in the 220 volt socket. Then it will step it down to 12 volts. So even if you check the level, you can see. So it can only from one input voltage 150 to 250, 50 to 60 Hz. Then they are charging voltage 14 to 14.5 volts, charging current maximum 10 amp. So instead of plugging it to 220 then to 12 volts, I can plug it directly. Like if it is 14 volts, I will plug it to if it's 12 volts, 15 volts can charge it. If it's 24 volts, maybe even if it's 30 or 40 volts, this charger controller can select the voltage and charge the battery safely without harming the battery. So like what I want to run is that I will couple this unmodified stator. Then because this motor on 24 volts, it run about 2000 plus RPM, which is not enough to excite the generator to bring current. So, but with my modify stator with 2000 RPM, this motor can give me current. There will be a current output because I've already modified it to tally with the speed of this motor on 24 volts. So let's experiment with it. So let me couple the generator. So first of all, um, okay, let me, so let me put the armature. Let me put the center load. So you can see. Let me tight it. Okay, so the generator armature is seated well, so there's no any vibration. So now I'm going to couple the generator, sit it on the frame. So remember, I haven't connected the modify lotto. So now I'm gonna run the motor so that you guys will see the speed. The speed is not up to 3000 on 24 volt, but on 36 volt you can run more than 3000 rpm. So this coil here is unmodified, which is suitable. It can only bring current on 3000 plus. So let me check first of all, check the speed of the motor. Let me connect my battery. So let me connect my battery. Okay, so I have already connected the battery from positive to negative. So at the end of it will be 24 volts. So let me use my meter to check. Okay, so from here 12.5 volts, 25.3 volts. Okay, so now I'm gonna connect to monitor the speed of the motor. So I have to put some tape here. Have to put some tape so that to enable me to monitor the speed. Let's the tachometer use it to detect the speed of the motor. Maybe it's too wide. Okay, so now okay, yeah, it's working. So now let me shift the camera. So I'm getting it. Okay, so now let me connect and run the motor. It's shifting. Okay, shifting. Let me excuse me. Let me press the it is not capturing it very well. Let me make it small. Okay, so now let me okay, 2000, not even up to 3000, not even up to 3000. Okay, 2002, 220. Just want you to see the speed. The 2400 and it frustrates. Okay, 2443. So the speed of this motor is 2443 RPM on 24 volts. So now we are going to put this generator to know if uh, 2443 RPM could excite this unmodified generator. Uh, so we are going to couple it then to see if this generator, if this the speed of this motor on 24 volts, which is 2400 and 444 RPM, could generate bring current. So let's couple the generator. Okay, couple the generator. Let's see. So now this capacitor is 24 volts UF. This big one is a 30 UF. So I'm going to put the two capacitors to know, because the higher the UF, the higher the value. So which we induce this generator. So I'm going to put it to know if at all it will generate output. So let me connect my meter, put it because it is on DC. So let me shift it on AC. So yeah, it is on now on AC. So let me put it. Let me connect the terminal of the meter to the output of the generator. Okay. So first of all, we connect this 24 UF capacitor to the generator. So I'm gonna connect it. So I've already connected it to the generator. So I've already connected. Let me on the meter. So I've already connected the 24 UF capacitor to the generator. Now let's run the motor and see. And see, just a small induced current. Okay. So now we are going to connect this big capacitor, this 30 UF capacitor. Know if actually it will generate a current. So let's connect. Okay, so we have already connected the 30 UF capacitor. This is the one we changed, the one I changed. So I've already connected the 30 UF capacitor to the generator. So now I'm going to test. So there is a current upgrade, a voltage upgrade. The previous 24 UF give us 18 to 19 volts, but this one give us 20 volts. So what does it mean? 2,443 RPM could not generate current output from the generator because it requires more speed to induce. Despite that, we put a 30 UF capacitor, but there's no output voltage. There's no output voltage from it. So now this is a modified status. So we are going to connect it to know if there will be output from it. Forget about the commutator I put here. It's not connected. I will just remove it. So let me remove it. It's not connected. So I just put it. Oh, strong. Something. Okay. So just normal induction armature. Normal induction armature. So now I'm going to dismantle this generator. First of all, let me use here. Then let me use here. So let me bring it out. So I've already bring the generator out. So now I'm going to dismantle it again. Let me take it. So now this is the unmodified unmodified coil, complete coil. So you can see it. So it couldn't generate anything less than 3,000 rpm. So it couldn't generate. So now remember the speed that the the generator is 2,443 rpm. So now I'm going to bring the modified stator in. I'm going to bring it in. So the modified stator. So let me know if it will give the same results with this unmodified, because I already wind it to suit the motor. Because the reason why I want to make it is that the this controller is 24 volts, so it cannot handle more than 24 volts when you put it. So I'm gonna couple this coil inside the generator. So I wind it. So okay. So let me put the ammeter. Put the center boot. So I like to take everything gradual, so that I understand it. Okay. When I tighten this, I make sure that I rotate this shaft to make sure that it is free. Because when it is not free, when you didn't tighten it to be balanced, when you didn't tighten it all the whole to be equal, sometimes it will be cracking, and when it is cracking, it will be consuming uh, energy from the motor. So that's why every time I tighten it, I make sure that I rotate the shaft to make sure that it rotates freely. So now I'm going to couple the generator to the frame, to sit it on the frame. So so I've already tight it. So let me tight this so that the generator will sit firm. Okay, so the generator sit firm. Okay, so now I'm going to connect. I'm going to connect the. Let me put the. First of all, I'm going to put this 24 UF capacitor to the generator. Okay. So now I'm going to connect the output of the generator to the multimeter to me to read it to know if there will be a output voltage. with the same speed. Okay, so I've already connected it to the meter. So remember I put 24 volt capacitor. Let me know if there will be output. Wow, this is 30 UF capacitor. This is 24 UF capacitor. So with 24 volts, I'm getting. Let me put it on 12 volts. I know on 12 volts it won't give a current. Let me check. Yeah, the speed is 8 volts. So with 24 volts, I could be able to get 170, 178 volts. Why this unmodified couldn't give me any meaningful volts? I think the maximum they give me with this 30 UF capacitor is 20 volts. 20 volts. So do you see the difference between unmodified and modified? Because I've already modified it totally with the speed of the motor. Okay, now let me put 24 volt. I mean this 30 UF. Let me see what will happen. Whether the voltage will increase. Okay, so I've already removed the 24 UF. Now I connect the 30 UF capacitor. So now let me run. Run it. Okay, difference. Slightly difference. Slightly difference. So this one give me 170 something, while this one give me 180 something. So which means this is 24, this is 30 UF. So let me run it again. So don't know if this I can check the speed again. I can check the speed again. Okay, the fan belt here is I think it is interrupting it. The fan belt here is interrupting it. The fan belt here is interrupting it. So let me check if I can put it on here. The fan belt here is interrupting. I think I guess. Let me put it here. So let me place it here. Let me know if it can capture it. Okay, let me know if it can. If it can. Okay, the speed even reduce. Yeah, quite alright. Okay, 2,116 RPM. Okay, 2,116 RPM. Despite that, despite the lower speed, it still give current. It still give current output because the coil has been modified. The coil has been modified. Despite that, despite that, it still give a current output. So I'm gonna connect. Let me connect this small bulb. Let me know if it can light it up. And can light it up. So let me connect this bulb. Let me know if it can power it. Power it. Okay. Wow. Still power it. So still power it. So so my demonstration today is to what I will do is this is for battery charger. This terminal is for battery charger. So this green wire is for battery charger. So I will what I'm planning to do is I will use a diode. And see, this is a diode. Here is a diode. So I will use this diode and convert it from AC to DC, then run it on this solar display input, then connect it to the but let me know if you can charge it directly instead of making use of this plugging it on 220, then because this charger can only charge 12 volts, can't charge 24 volts, so it's only meant to charge 12 volts. So this motor is 2436 volts, can operate on 12 volts, 2436. So now if I put it on 12 volts now, the motor is running but on lower speed, so there's no any output. So what I plan is that we put this I will use this charger. This charger will be monitoring the charging the battery. So I will try it and see how far. Remember the previous coil I tested didn't give you any current because the speed is lower. The speed of the motor is lower, so it needs something like about 3000 rpm or 3000 plus to give you a current. But this coil I've already modified it, so I've already modified it to suit totally with the motor. So you can see when the motor is running without load, it's run on 2443 rpm. But when I connected load and when it has already excited the armature because it has already formed electromagnetic inside, so the speed dropped to 2100 and I think 113 rpm or thereabout. So it still give output. Why this didn't even induce any current? So the current it induced is this permanent magnet here. That is what give the voltage you see. So that is this uh, strong magnet you see here. So that is the output. So without this magnet, there's no any output. You see. So the magnet is strong. Magnet is strong. The magnet hold the ply firm. So like what I'm trying to display in this video is that um my next step now is how we connect this diode to this uh battery charger in one dielectric. Instead of using this charger, I will use this, and this can charge up to 24 volts. The maximum is 24 volts, so I'll use it to charge this battery. uh Let me know if it can continue working. And there's another thing I want to say. I'm not here now in this concept now, I'm not trying to create any energy. I'm not trying to create any energy because this generator has a rated power. I think 950 watt to 1000 watt. Maximum is 1000 watt. Remember when it's run with gasoline engine, which is about 2 to 3 horsepower. 2 to 3 horsepower. So I'm not trying to create any energy. I'm trying to um, use this available energy here so that the system can be recycling. I'm not trying to convert this 950 watts to 2000 watts or 3000 watts. No. For those of you that got me wrong, I'm not trying to create any energy. But this generator has a rated power which is about 1000 watts, 1000 kilowatts. So inside that 1000 kilowatts, I'm trying to use this motor. This motor will drive this generator, and when this motor take energy from the battery and drive this generator, I will use the available energy inside the generator and return it over to this battery here. Then it will be working from here to here, from here to here, from here back here again. Then I will use this charge controller. This is meant to solar, but it can work here. I will use it to know. Let me connect it. Let me know if it's working. I will connect it here so that this thing will be monitoring. It won't overcharge or give high voltage to this battery, because once they give high voltage to this battery, it may damage the cell of this battery. So let me connect it. Let me check if the battery is working. The controller is working. So here is the, the positive. This is the sign. Then here is the negative. Okay. Okay. The battery has up to 24.9 volts. 24.9 volts. So let me put it on 12 volts. Let me see. Okay, 12.4 volts. Okay. So I'm not trying to create any energy, but I'm trying to self-run, like recycle the energy self-loop. So for those of you that got me wrong, I'm not creating any energy here. So that is the concept. So stay tuned. My next move now is that I will connect this, since I've already wind the battery charger directly, no need of connecting it in the mains output. So I will just run it directly, because the maximum input this controller can handle is 50 volts. So it's, see it boldly here. So once it surpasses that 50 volts, it will damage this controller. So stay tuned for my next update. So like I stated clear, this didn't give me any output. This is modified, and this is factory wind stator and loto, which is armature. But this is modified stator. You can see when the motor is running on 2000 RPM, 2000 plus RPM, it give current. Why this one didn't give any current? It didn't give any current. So I already modify it to suit the speed of the motor. So stay tuned for my my next video. If you have any comment, if you have any feedback, feel free to drop. So I try different concepts. I try different. I make a lot of experiments um, for the project. So stay tuned for my next experiment. Thank you for watching.